Okay, good morning all. I will be presenting to you a lesson on adding and subtracting fractions, and this will include worded problems. So again, today we will be looking at adding and subtracting fractions. We will investigate some of the rules for doing these. Then we will also be looking at worded questions which use the same rules. Now, before I begin the lesson, there are a few vocabulary words that I would like for you to become familiar with that we will be coming across during the lesson. The first one is fraction. Of course, you need a working definition for the word fraction. What is a fraction? A fraction is, of course, a part of a whole. Okay? When we talk about fractions, we talk about a top and a bottom. The top number we identify as being the numerator, and the denominator, of course, is the bottom part of the fraction. We would also be meeting up with the term equivalent fractions. What is an equivalent fraction? An equivalent fraction is a fraction that is equal in parts, okay? So remember, even if the denominator and the numerator are different numbers, that equivalent fraction will still be equal. Next, I want you to remember the word LCM, or the term rather, LCM. What is an LCM? You should have learned from previous lesson that an LCM is lowest common multiple. All right, now what is the lowest common multiple? The lowest common multiple is when you would have found the multiples of two numbers, you would then choose the lowest multiple that is common between both of the numbers. Okay, great. So let's jump right into our lesson. Adding and subtracting fractions. You're gonna meet up with two scenarios when you're looking at adding and subtracting fractions. In the first case, you're gonna have a situation whereby the denominators are the same. Okay, we call it like denominators or like fractions. Okay, when the denominators are the same, you want to keep it as such. You're not gonna do anything to the denominators, but rather you're going to look at the numerators and you're going to either add or subtract your numerators. In this case, if you look at the screen, you would see where the denominators are the same, that being 4. So now again, you want to work only on your numerator. You want to now only work on your numerator. So here we have 1 and 2. We have 1 and 2. And when the denominators are the same or alike, we don't have to worry about it. We just keep the denominators. However, you must follow the rule, whether it's addition or whether you're adding or subtracting the fraction. In this case, we are adding. So we have 1/4 that's being added to 2/4. And again, the denominators are the same, so we do not change the denominators. We keep it as such. So 1 plus 2 is 3. And as you can imagine, your answer will be 3/4. Okay, the next scenario we will encounter is when the denominators are different. When we have different denominators to deal with, what we want to do is we want to find the LCM. Remember in the beginning, I said to you, the LCM is multiples. The LCM is the lowest rather common multiples of two numbers. Okay, in this case, we have 3 and 4. So we want to go ahead and find the LCM or list the multiples first of 3, and then we're going to list the multiples of 4. Then we're going to look at both of the listings and we're going to choose the lowest common multiple, or that multiple that is common to both of the numbers. And again, in this case, our LCM will be 12. Once you would have found the LCM, the first thing you want to do is you want to divide each of the denominators of both fractions into that LCM. Again, in this case, we have 3 and 4 being our denominators. So we want to firstly divide the 3 into 12, okay? Or in other words, how many groups of 3s can I get out of 12? Okay, once you would have found that, then you would multiply that answer by the top number. You want to multiply that by the top number. Okay, sorry, let's go back. So here we have 12 being divided into 3. Okay, how many groups of 3s can I get from this LCM? 12. Okay, and I can get 4. Okay, you take the 4, you look at, again, the numerator. You want to multiply that 4 by the 1 in this case. So 4 times 1 is 4. Okay, and remember, once you would have found the common denominator, in this case being 12, you want to keep that throughout. Okay, next you want to look at the second part of the fraction. You want to see how much groups of 4s can you get out of 12. In this case, 3. So you want to multiply your numerator for that part of the fraction by your answer. So 1 times 3 is 3. Okay, then once you reach this stage, then you just follow through and do as the sign suggests. In this case, you have 4 plus 3 equals 7. And again, we have found our common denominator, okay, or the LCM, which is 12, and we want to keep that. Okay, next, I want to show you what to do, which is similar when the sign becomes subtraction. Okay, in this case, we have 4 over 5, or 4/5, and it's being subtracted from 2/3, or 2 over 3. Okay, again, look at the denominators. They are different. So again, what we want to do is we want to find our LCM for the denominators. In this case, our LCM will be 15. And again, the LCM is found by listing the multiples of both the denominators, and you're going to find that number, that multiple rather, that is common to both. Again, 5 and 3, my LCM will be 15. What do you do once you have identified your LCM? You want to again divide each denominator, okay, into that LCM. Or again, ask yourself, how many groups of 5, in this case, can I get from 15? Okay, once you would have done that, then you do what? You multiply by the numerator. So 5 into 15, we get 3. 4 times 3 is 12. Subtract, again, 3 into 15. How many groups of 3s can I get out of 15? Okay, 5. Then you multiply that by that second part of the fraction. In this case, we have 2. Okay, and our answer being 10. What do you do once you have reached this stage? You do as the sign suggests. In this case, it's 12 less or 12 take away 10. Okay, and your answer, of course, it's going to be 2. And then again, we have found one common denominator, so we're going to keep that. Adding and subtracting a fraction, we have an example for you to look at again and to try and work with me. In this case, again, the first thing you want to do is you want to look at your denominators and decide whether or not those denominators are the same. Okay, in this case, we have 6 and 8. Denominators are different. What do you do? Again, you want to find the LCM, or the lowest common multiple of 6 and 8. In this case, it's going to be 24. Okay, once you would have identified your LCM, you want to now divide. Okay, how many groups of 6? 6 in this case, sorry, can you get out of 24? And then, of course, you multiply your numerator by that number. Okay, so by now, I'm hoping that you're getting a feel for what is going on here. So then we multiply, okay, our answer we end up with, 4 over 24, and that will be added to 15 over 24. Okay, and we're going to end up with 19 over 24. Another problem, for you to work on, for us rather to work on. We have, again, you want to look at your LCM. LCM, again, in this case, they're different. We have 5 and 7. The LCM of 5 and 7 is 35. What do? Good. You want to divide each part of your fractions denominators now. Remember, you're only dividing the denominators, okay, of those two fractions into this newfound or this new denominator, again, which we call our LCM. So we're going to say 5 into 35. How many groups of 5s can I get out of the 35? And then you're going to, of course, multiply the numerator by that answer. Okay, in this case, we end up with 21 over 35, and that's being added to 20 over 35. Okay, now another way that you could have done this, you could have said 21 plus 20 and just put 35 one time rather than splitting it up the way that I did. But it's quite all right. It would not make your answer incorrect. Okay, so again, denominators are the same. So we're going to keep the denominators and we're going to work on the numerator or the top part of our fraction. And again, in this case, we have 21 that's being added to 20, and we're going to get 41 over 35. Okay? Now, this 41 over 35, as you may know, is called an improper fraction. Another topic that you should have done in a previous lesson. What is an improper fraction? An improper fraction is when the top of the fraction is greater than the bottom of the fraction. Okay, what do you do then? And we also call this simplifying, okay? You want to always simplify your fraction as much as you can where possible. So I'm going to simply divide the denominator into the numerator, okay? Or ask yourself, how many groups of 35 can I get out of 41? Okay, 1. I can get 1 group of 35 out of 41. That 1, remember this now, very important, that 1 will be your whole number, okay? And I have a remainder 6. What do you do with that 6? You take the 6, that would be the numerator for your fraction part of this mixed fraction. So you have 1, you have 35 into 41, going 1 time, remainder 6, and you again keep that denominator, okay? So you have a mixed fraction being 1 and 6 over 35. And remember, the whole number is how many groups of that denominator you got from that numerator, okay? Okay, another slide should have popped up for you. You're being asked to calculate the perimeter of a patio, okay? Now, this is where real life situations kick in. You know, kids tend to always say, well, why do we need maths? You know, where can we use that in real life? Well, here it go. If you're being asked to find the perimeter of a patio, the perimeter of this patio is 2 3/4 by 4 1/3 yards, okay? So you're being asked to find the perimeter of the patio. And again, you're going to add 4 1/3 plus 2/4, okay? Again, what you're going to do, you will have to change the mixed fraction, okay? When you have 2 fractions being added together, accompanied by 2 whole numbers, remember, okay, what you want to do firstly is you want to change it to an improper fraction. How do you do that? Again, something that you should have been taught in a previous lesson. You want to multiply the whole number by the denominator, and you're going to add the numerator. In this case, we have 4 1/3. So we're going to say 4 times 3 is 12, and we're going to add the numerator 1 to get 13 over 3. And notice now you're going to keep the denominator for that first part of the fraction, okay? You're not going to work on that yet, okay? So again, change the mixed fraction to an improper fraction by adding the whole number and the denominator and adding the numerator. You want to do the same thing with the second part of the fraction, okay? Again, 2 3/4 becomes 2 times 4 and add 3. 2 4s are 8, add 3 is 11. And look, I kept the 4, which is the denominator or the bottom part for that second part of the fraction. Okay, good stuff. What do you do next? Denominators are different. I am going to find my LCM. LCM of 3 and 4 in this case is 12. What do? You want to divide each of the denominators into that LCM. 3 into 12, okay, in this case, and then you're going to multiply the numerator, good stuff, by that answer. Second part of the fraction, you do the same thing. 4 into 12 times the numerator. Okay, so you're going to end up with 52 add 33. And as I was mentioning earlier, you can draw a line, okay, that separates my new or my LCM from the numerators, okay? And you can add it this way, or as I did in the previous slide, I separated them. It would not give you an incorrect answer, okay? So here we have 52 being added to 33, and again, our common denominator, our LCM, is 12 that we're gonna keep, okay? So we have here now 7 1/2, okay? 7 1/2 is my answer. So the perimeter will be double, because remember now, by definition, perimeter is defined as an addition of all of the sides of a shape or figure, okay? So once you would have added, your 52 and your 33 to get 85 over 12, the LCM, what do you want to do? Because that is an improper fraction. Remember what I said you do when you have an improper fraction. You want to find out how much of that denominator can you get from that numerator. In this case, we have how many groups of 12 can I get from 85? 7, correct, okay? So you want to put that as your whole number. And remember what I also said, the remainder is put over that LCM. So now you don't change the LCM, you keep that LCM because you would have found the common denominator, okay? So you're going to divide again 12 into 85, which gives us 7 with a remainder of 1, and you keep the denominator. Okay, so again, the perimeter will be double. So here we have 7 1 over 12, or 7 1 12. When you double that, you get an answer of 14 2 12. Do you see what I did? I doubled it, yes. Okay, so we end up again with 14 2 12. Now look at the fraction part of this problem. Look at the fraction part. That can be simplified. Okay, 2 12ths can be simplified. And again, remember when we spoke about equivalent fraction? Good. You want to simplify that, and again, it's not going to change the value of the fraction. The fraction will still be equivalent. So you find a number that can be divided into both the numerator and the denominator when you are simplifying. In this case, I have 2 and 12. 2 can go into itself once, okay, and 2 can go into 12 6 times. There you have it. My fraction is simplified. So I end up with 14 1/6 yards. Okay, going to my next slide. You have another worded problem coming at you. Another real life situation we have to deal with. Don't you just love real life situations? I do. Okay, it says a house has a vertical height of 8 2/3 meters. If the 2 floors are 5 6 7 meters high, what is the vertical height of this roof? Okay, Now, if you look at my diagram, okay, what are you being asked to do? That's the first thing when you have worded problems, that's the first thing you want to ask yourself. What is this question asking me to do? Okay, so here you have this house. The height of the house is 8 2/3. Okay, that's the total height of the house. Now it's saying that the 2 floors, okay, so that's from the ground, and it stops at the tip of the roof, as you can see, measures 5 and 6, 7 meters high. What is the vertical height of the roof? I believe this question is asking me to find the difference. Indeed it is. 8 2/3, I want to subtract that from 5 and 6, 7. Now, look at the two types of fraction we have. We have two mixed fractions. Again, a mixed fraction is simply a fraction that has a whole number attached to it. Okay, in this case, we have 8 2/3 minus 5 and 6 sevenths. Remember the first thing I said to do when you have mixed fractions to work with? Yes, you want to change those to good improper fractions, because this makes the fraction easier to work with. And again, that's found by simply multiplying the whole number by the denominator and adding the numerator. Okay, so you want to multiply your 8 times 3 and you're going to add 2 to get 26. What do? We keep that denominator of that first part of the fraction. In this case, it's 3, and you see I kept 3. Watch your signs now, because I know my students tend to sometimes want to add everything. Everything is addition. In this case, we are going to subtract. Okay, so now you want to work on the second part of that fraction, which is, again, also a mixed fraction or a mixed number. What do? You multiply the whole number times the, good job, times the denominator, sorry, and you're going to add the numerator. So you're going to say 5 times 7, add 6. Okay, my answer is 41. And look, the denominator is 7. So I want to keep that. Now, look at what we have here. We have 26 over 3 being subtracted from 41 over 7. Those denominators look different to me. Not sure about you. However, because they look like they're different to me, I am going to find the LCM of 3 and 7. Okay, in this case, or which is rather 21. Okay, once you would have found the LCM, and again, that's the lowest common multiple, or the multiple that is common to both of those numbers when you would have listed the multiples. Okay, again, that is the lowest multiple that is common to both of the numbers when you would have listed the multiples. Again, in this case, we have 21. What do you do when you would have found the LCM? You're going to divide. What are you going to divide? You're going to divide each of those denominators. Ask yourself, how many group of 3s can I get out of this 27? Okay, once you would have found that, what do you do next? You want to, yes, multiply that by the numerator. And you want to do that with both fractions. So now you're going to do 7 into the 21 multiplied by 41. Okay, so here we end up with 182 minus 123. And again, it's all over my newfound LCM, or my LCM, which in this case, again, is the 21. So 182 less or take away 123, it's 59 over, look at that. We are going to keep our denominator or our LCM. Okay, because remember now, we would have made that common, so we're going to keep that. Okay, take that right over and let that 59 sit right on there. Look at the 59 over 21. Can somebody tell me what is that type of fraction called? Good stuff. It's called an improper fraction. Why? Because again, the top is bigger than the bottom. Okay, that is an improper fraction. what do? You ask yourself, okay, how many 21s can I get out of 59? 2. Good stuff. Do you have anything leave over? Yes, you have a remainder. You have a remainder of 17. What do you do with the 17? You put it over the same denominator, again, which is also called our LCM. Okay? I have another one for you. Another worded problem. In Mark's class, half the students' favorite color is red. 1/3 prefer blue and 1/10 prefer green. What fraction of the class prefer a different color? What fraction of the class preferred a different color? Again, we're adding these fractions. Again, you want to read over your worded problem. You want to read that at least 3 times so that you can get a complete and total understanding of what the question is asking you for. Don't just peruse it once and try to attack the question. You want to read your worded problems at least 3 times. Once you would have had or gathered or gotten an appreciation for what the question is asking you, you can then work on your problem. Okay, I'm jumping the gun a little bit here. Okay, so we have 1/2, right? We have that being added to 1/3 and 1/10. Okay, as the question suggests. Now look, even though we have 3 fractions now, it does not change the rules. The rules remain the same, because I know sometimes I have students, oh, well, Miss Lindsay, you showed us how to do it with 2 fractions. Now we have 3. What do? Duh, you do the same thing. All rules apply, no matter how many you have, okay? Good, so here we have 3 fractions being added together. We have 1/2 again, 1/3, and 1/10. What do? We don't have any whole numbers there, so we have proper fractions, so we can go straight into finding our LCM. Now, again, the LCM is simply the multiples of the numbers when you would have found the multiples of each of the numbers. You're going to identify the lowest as being your LCM. So you have here 2, 3, 10. What is the LCM of 2, 3, and 10? Now, students, I want you to remember, you have to be accurate when you're finding your multiples of each of these numbers, because sometimes I find that students may skip over a multiple and jump to the next. That can create a problem, because guess what? The multiple that you choose may not be the lowest, okay? So be careful and ensure that you are not skipping over any numbers, okay? So now my multiple of 2, 3, and 10 is 30. What do? You want to, again, divide each of those fractions, denominator, or the denominator for each of those fractions into the newfound LCM. In this case, I'm going to firstly divide my 2 into 30. When I would have found the answer, I'm going to multiply the top number or the numerator. Okay, so 2 into 30, we get 15. 15 times 1 is 15, added to 3 into 30 is 10 times 1, 10, good. Lastly, we have 10 into 30, 3 times 1 is 3. Good job. Okay, what do we do now? Remember what I said. The next step is to add the numerators. Once you would have gotten the denominator to be the same, you don't have to worry about that anymore. That just goes over, it travels over with you. So here we want to work on these numerators. We have 15, 10, 3. That should sum 28. And what do? Keep the denominator or the LCM that we have found. Good stuff. All right, now look at 28 over 30. Look at 28 over 30. Can somebody tell me something about that fraction? I'm going to give you 1 second. Good stuff. That can be simplified. Okay, that can be simplified. And remember, it doesn't change the value of the fraction because it's an equivalent, meaning that it is an equal fraction. Okay, so I hope by now that everybody understands fully what's going on with these fractions. Okay, what you want to do, you ask yourself, what number can I divide into both this numerator and denominator such that I don't get a remainder? Now, I like to tell my students, when in doubt, we always supposed to use the largest number that can go into them. But when in doubt, you can start with the smallest number, okay? And if you have even numbers, that will always be 2 in most cases, okay? So here I'm going to start with 2, okay? 2 into 28, you get 14. Same 2 now, don't switch on me. Don't switch the number. 2 into 30, you get 15. And that is an equivalent fraction, and it is in its simplest form. Okay, good stuff. You still need to answer this question now. The question is asking you, what fraction of the class prefer a different color? Okay, so 14 over 15 are the portion or the fraction of the class that like red. Don't just leave now. Don't just leave it at that, because you have not answered the question. You have only found out the portion of the class that like red. 14 over 15 like red. Okay? And another thing I want you to remember. Remember now, I said that fraction is a part of some whole. How do you tell what that whole is? By looking at the denominator, students. You look at the denominator. So it tells me that my fraction, the total parts of my fraction is 15. What number, when you look at the numerator, what number that when you add to that numerator, you would get 15? 1, of course. Okay, so 14 plus 1 would give me 15. So now, remember now, think about it. 15 over 15 is equal to 1. Another point to remember, whenever you have a fraction whereby the numerator and the denominator are the same, guess what? It equals to 1. So 1 over 15, if I add it to 14 over 15, I would get my 15 over 15, which would account for the whole class. Okay, so 1 and 15, or 1 over 15, prefer a different color, whilst 14 over 15 prefer red. Now, I hope I haven't lost anyone up to this point. Okay, this I believe is my last example. And I want you to bear in mind that even though you may have variables, letters in your fraction, it does not change the rule. Here we have x over 2 plus x over 3. Again, denominators are different, so what do you want to do? You want to find the LCM. LCM of 2 and 3 is 6. Then you want to divide each of the denominators into that LCM. 2 into 6, you get 3. So you're going to times the 3 by the numerator. Good stuff. And in this case, it's x. So 3 times x is 3x. And again, you keep it over the newfound LCM. You do the same thing to the next part of the fraction. 3 into 6 is 2. 2 times x, which is my numerator for the second part of the fraction, becomes 2x. And again, you keep it over the common multiple, which in this case is 6. Then you want to work on the fraction. If this fraction says to add, so you're going to add 3x plus 2x gives you 5x. And again, you want to keep your common multiple. Good stuff. And again, I hope to this point I haven't lost anyone yet. So we're going to summarize this lesson. So step 1, change all mixed numbers into improper fractions. Okay, so when you have fractions to work on and you have a whole number attached to the fraction that's a mixed fraction or mixed number, you want to change that to improper fraction. It makes it that much easier to work on. Step 2, if the denominators are the same, and if the denominators are not the same, you want to find the lowest common multiple, or the LCM. Step 3, you want to divide that LCM into each denominators. Okay, each of the denominators for the fractions, you want to divide the LCM into those. Then step 4, you want to multiply that answer by each numerator respectively. Okay? Step 5, you want to simply do as the signs suggest, and remember to watch the signs. If the sign says, to add, you want to add. If it says to subtract, you want to go ahead and subtract. Okay? Keeping the newfound denominator or the LCM. Now, step 6, I know I have up on the screen where it's optional. However, I always encourage students to simplify your answer as much as possible. Okay, it would not change the value, but it just shows your knowledge of equivalent fractions and how well you know how to work on fractions. Okay, now I have a few questions for you to work, a few problems. I want you to copy down as quick as possible, and you can attack one or two of them. If you have questions in the interim, you're gonna type your questions, and there's somebody standing by who will answer these questions for you. But again, I want you to try at least the first one and the sixth one. Question number 1, okay, those are addition of proper fractions, and then question 6 is different. It has attached to it a whole number whereby you can show me your skills, or you can show your skills or your knowledge on how to work on mixed fractions. Okay, I hope you enjoyed the lesson, and good luck in the future with fractions.
Hi, welcome to Grade 2 Math with Mrs. Farrington. That's me right there. And today we're going to be looking at fraction. We're going to be talking about fractions. And I'm going to start with a story about 2 friends. And these friends are Lene and Kalika. They're very, very good friends. So, Lene on Friday, she went to Miss Rule and she bought a coconut tart. Lene shared her tart with her friend Kalika because they're like best friends. Both girls were really happy and everything was cool. So on Sunday after church now, Kalika bought tart as well. She went to Miss Rule and she bought tart after church. And then she shared it too with her friend. Kalika took a piece and then she gave a piece to Lene. Now, Lene took one look at her piece and then she looked at Kalika's piece and she said, Kalika, you ain't fair, you know. You ain't fair, you big eye. So Kalika was like, what you talking about? I share my tart with you. I break it and I give you half. Kalika was like, no, 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 no. So Lene was like, no, you didn't give me half. You gave me a piece, but it wasn't half. She said, look good at your piece. Your piece is bigger than mine. So, is Lene correct? Let's look. We have, this is Lene's tart, and this is how she separated. She took a piece and she gave Kalika a piece. This is Kalika's tart, and Kalika took a piece, and then she gave Lene a piece. So when we look here, Lene would have made sure that she and Kalika had the same size. But when we look at Kalika's, we can see that Kalika's piece is much larger than Lene's. Now in math, equal parts means to have the same weight, size, or quantity or other measurements. So it's the same. Remember when you did even numbers? Even numbers can share equally without a remainder. So it's the same size. Now, unequal parts in math is when we have parts that are not exactly the same weight, size, or measurement. There's always one that's bigger. Like in odd numbers, there's always one left over. 3 is an odd number because you get one, I get one, and then you get one, but there's no more for me to get, so one will get more. So it's unequal. Now, how does this, well, what does this have to do with fractions? Well, I'll tell you what it has to do with fractions. A fraction is a part of a whole. When we put these together, this is Lene's tart, that's the whole tart. This is Kalika's whole tart. A fraction is a part of a whole. Now, both of these are whole, so we can say this is a fraction and this is a fraction. But we wouldn't be correct because fractions have to be equal. All the parts must be equal. So Lene she gave her a fraction. She gave her half because these are equal. They're the same size. Kalika, on the other hand, this is not a fraction. These are unequal parts. Kalika's part is clearly larger or bigger than Lene's part. And so, no, Kalika was not fair in the way that she shared it. Now, we can't say she's big-eyed. Maybe Kalika just can't cut. Maybe that's it, but we can't just say she's big-eyed. But that's Lene's friend. You don't get in that because they're going to be friends later. So, now let's look at further at Lene's. We're going to use her part, her tart. So, Lene took a piece. So she gave one to her friend. And there were 2 pieces in all. So that's the fraction. She had one. She had 2 pieces in all, and she gave her friend a piece. So what fraction? She gave her friend Kalika 1 out of the 2 pieces that she had. All right. So 1 and 2. But when we're talking about fractions, we just don't say 1 and 2. These numbers have special names. So I'm going to sing you a little song. I'm not a music teacher, but I'm going to sing you a little song so that you can remember what we call these numbers. And it goes like this. Each number in a fraction has a name. Each number in a fraction has a name. On the top, the numerator. On the bottom, the denominator. Each number in a fraction has a name. So, like the song said, each of the numbers have a name. So on the top here, we have if you were listening or you were singing along, because I know you catch on really fast, the number at the top is the numerator. And then the number at the bottom, the denominator. So those are the special names. They're really big words, but you'll remember because numerator and denominator. But there's also another part. There's also another part. What about this? Miss Farrington, that's the line. That's the line. Yes, it's the line. But that line also has a special name. This line is called the fraction bar. It's called the fraction bar. So at the top we have the numerator, at the bottom the denominator, and then the fraction bar is the line that separates them. So your denominator tells you how many pieces there are in all. There were 2 pieces in all. And then your numerator will tell you about the pieces that are shaded or the piece that the problem speaks to. For instance, which fraction did Lene give to Kalika? She gave her 1. So she gave her 1 out of the 2 pieces. So the fraction there is 1 out of 2, or a word that we use a lot. I know you know this word. Another word. This word. Because they talked about it. Half. Half. 1 out of 2 is half.